at this stage I really want to get back to what they might actually ask you in the exam. So I'm going to come up with something that you might actually get asked. So it might say something like this. So show 5 over root 5 in the form of n root 5, where n is an integer. I'm not going to write that in, but where n is an integer, some non-decimal number. So how do we go about doing that? Well, we kind of did it in the last one, but this one's going to be a little bit neater than that. So what we're going to do is we're going to use the same logic as we used in the last video. So we're going to say we have 5 over root 5, and in order to get rid of this surd on the bottom, what we can do is times it by itself over itself, that same surd. So this root 5 times by root 5 over root 5, and what that does is gets rid of the surd on the bottom of the fraction. So what's that going to be equal to? Well, what we're going to have on the top is we're going to have 5 root 5 over the root of, I'll do it longhand, the root of 5 times by 5, and then in green what we're going to get then is 5 root 5 over the square root of 25, which is 5. Square root of 25 is 5. And then what we can do with that is say, well, that is equal to the root of 5. The 5's cancel. So what we have there is n equals 1, and that's the kind of thing that you might get asked to do in the exam. That might be 1 mark, maybe 2 marks. But I'm going to go on to show you something a little bit more tricky than that. Give myself some room. So it uses the same concepts as this, but there's kind of like a trick that you have to learn for doing this. So let's say you get given 3 plus root 7 over, I don't know, let's say 5 minus root 7, and we get told that we need to eliminate the surd as our denominator. So how do we do that? Let's use the same logic that we used here with these root 7s, but there's a trick. What we're going to do is times by this whole denominator, but we're going to change the sign. So I'll explain what I mean. So we're going to times by 5 plus root 7 over 5 plus root 7. And I'll come back to, I hope you see it actually, I'll come back to why we've changed that sign there to get rid of it. But it should become clear. So let's go about it as usual. This top is going to look quite messy, but don't worry about that, it soon clears itself up. So 3 times 5 is going to be 15. Then we're going to get plus 3 root 7, then plus 5 root 7, then root 7 times by root 7, I hope you got this by now, is 7. So then plus 7. So then as our denominator, this is where the trick comes in. So let's have pink. So actually let's not have pink, that's not going to go very well with the green, I don't think. So we have 5 times 5. 5 times 5 is going to be 25. Then we're going to have 5 times plus root 7, so plus 5 root 7. Then we're going to have 5 times by minus root 7, so minus 5 root 7. And then we have minus root 7 times by plus root 7, so minus 7. And I hope you've seen what's happened here on our denominator. What we have is a plus 5 root 7 and a minus 5 root 7, because we changed the sign here. So we get these cancelling each other out, and then we are left with 2 integers as our denominator. We have no more surds on the bottom of our fraction. So then we can kind of tidy up this top. We can have the 15 and the 7 added together. That's going to be 22. It's going to be 22. And then 3 root 7 plus 5 root 7. That's going to be 8 root 7. I nearly said 7 root 7. That's going to be 8 root 7. Leave that like that. Over 25. Ignore these two because they cancel each other out. 25 minus 7 is going to be 18. And then, because I just pick these numbers at random, it doesn't come to like a neat fraction, but in the exam you might get a kind of neater one. But we can tidy that up a little bit. We can say that that's equal to 22 over 18 plus 8 root 7 over 18, which is equal to 11 over 9, just dividing by 2 here, and then plus 4 root 7 over 9. Then if you want it to be really neat, you could say that's 11 plus 4 root 7 all over 9.